Hi everybody, this is lesson 2.5. We're going to be going into application questions. So usually what happens is when we finish teaching you all about the concepts like solving equations, isolating variables, and so on, we would then apply them to some sort of a word problem. So that's going to be our goal for today, to solve word problems. All right, now the success criteria or learning goals that we're going to have for this lesson we're going to see if we can read the question and draw a diagram, because a lot of times a picture will help you to be able to visualize the problem. And once you get a picture, you start to form an equation. So this one right here is actually the hardest one to do, is create an equation, and you're basically translating the word itself into math numbers and symbols. So after you have those numbers and symbols in an equation, you can then solve it using any of the tools that we had taught you from 2.1 to 2.4. And lastly, what you're going to do is you always want to just check to make sure that you got the right answer, to see if your answer makes sense. Okay, so before we get into a question that has all four of these things, why don't we practice just the hardest one, which would be translating the math into an equation itself. Okay, so that's what example number 1 is. I'm giving you different sentences right here, and we're going to start to translate them into equations. All right, so you can see my work already done, but let me go through them with you. Okay, so first of all, example number 1, write or create an equation for each of the following. Now, when it says let x represent the unknown number, they mean that in the question itself, it's going to say a number. And when they say a number, we don't know what that number is. And so what we want to do is use a variable or a letter to represent that number. So when it says a number, you can use any letter you want. And usually we use X, but you can use A, you can use W. It really doesn't matter. Okay, but we're just going to put an X right there. Now we're going to continue to translate with symbols and numbers and see if we can kind of change all these words into math instead. So when it says a number, we're going to put X, increased by, so notice that increase means go up, like plus, some sort of an addition. So I just underline that in red, and I'm just going to put a plus symbol. So increased by 3. So that 3 right there I underlined in blue, and I have the blue 3 right above. That word is usually represents an equal sign. And then 10 is just a 10. So when we write a number increased by 3 is 10, we mean a number added by 3 equals to 10. Do you see that? So we're just translating the words into some sort of an equation because you guys know how to solve this equation now. Let's try it again. So for B, 3, so I put a 3. More than, so more than is another set of words that means addition. Twice, so twice means like double or 2 times something. So when they say twice a number, they mean 2 times, and remember a number is going to be, we're just going to represent it by X, so we're just going to put X right here. So twice a number means 2X is 19. So 3 more than twice a number is 19. Okay, now the next one. 4 times a number, so 4 times, and you don't have to put the dot if you don't want to, but you know that they're multiplying each other. Decreased by, so now decreased by is the opposite of increased by, so it should be a subtract. 7 makes, so equals, negative 35, so negative 35. All right, so 4 times a number decreased by 7 makes negative 35. So if we translated it into this sentence right here, okay, this mathematical sentence. All right, so now that we've practiced that a little bit, what I'm going to do is I'm going to go through 2 more examples, but these are the ones where we're going to start drawing pictures. So this is what an actual question might look like, say on an assessment, like a quiz or a test, or in your homework. Example number 2, the perimeter of a rectangular garden in the city park is 63 meters. if the width of the garden is 11 meters, what is the length of the garden? So we're going to go through steps in order to figure this out. Now, the first thing I want to do is I want to draw a picture. So when they say rectangular garden, I drew a rectangle right here. All right, and they told me the perimeter is 63 meters. Now remember, a perimeter means you're going to add the widths and the lengths all together. So we have 2 widths and we have 2 lengths. And when we add them all up, we're going to get 63. Now I just decided to put that in the middle for now to keep that information there and I can see it. Okay, now they gave us some other information. If the width of the garden is 11 meters, okay, so the width is usually the shorter side. So here's the shorter side, and here's the shorter side. Both of those are 11. And make sure you just follow my colors. So the red right here is also the red right here. Okay, so the green for the perimeter, I just put in the middle. Now it says, what is the length of the garden? Since we don't know that, why don't we just put 2 L's? Or if you want, you can put those X's again, that's fine. Any letter you want, but I decided length, just use L. So I'm going to put that in blue right there, color-coded with this. Okay, so that first step in my learning goals right here was to draw a diagram. The next thing I want to do is create an equation, because then I'll be able to solve my equation and then check my answer. All right. So that next step is to create an equation. So remember, the perimeter is calculated by adding all the sides together. So I put perimeter is equal to L and another L, so these 2 L's added together, plus the 11 and the 11 added together. Now that is my equation right there, and there were some things that I knew about my equation, like I know what the perimeter is. They gave it to me, it was 63. So why don't we replace the P, the perimeter, get rid of that and just put a 63 instead. And I decided to clean up any like terms I have on this side of the equation. So those 2 blues I can put together, 1 L and another L, make 2 L's. 11 plus 11 is 22. Now remember, you can't add these 2 together because they're different colors. One has an L and one doesn't. So that is our equation and we just leave this alone for now. All right, now the next step was to solve the equation. So what I did was I rewrote this equation and I put that right up here, just to start on a new line. Okay, now in order to do this, I'm going to start to highlight to show you what we did. Here's an L by itself, okay? Or rather, it's not by itself. It has a lot of stuff beside it. It has a 2 and it has the 22. Now I'm going to highlight these numbers that don't have L's. So these 2 don't have L's. We want the yellow by itself and we want the greens to be together. So notice that I circled this and I put it over on this side because I wanted those 2 greens to be together on the left-hand side and I wanted the yellow to be on its own on the right-hand side. So because I didn't move the 2L, nothing changed, but I did move that 22 to the other side. It was a positive before. Now notice it's a negative. Okay, we didn't change the 63 because it didn't move. All right, so the answer to 63 minus 22 is 41 right there. And this 2L is going to be right here. Okay, now that last step is we want L by itself, so we're going to get rid of that 2, and we do a division on both sides. Divide by 2 and divide by 2. So your 1L, which is right here, is going to equal to 41 divided by 2. That's going to give you 20.5. So our length is 20.5. And that's what I wrote in a therefore. So we always want to finish off our answer with a therefore statement. And we want to write it in words. So the length is 20.5 meters. Don't forget your units because they told you what the units were in the question itself. All right, and some of you guys asked me before, what are those 3 dots? So those 3 dots means therefore. It's a symbol for the word therefore, or in conclusion. The last step that we want to do is we just want to check our answer. So let's say that our length is 20.5. Okay, so now what I'm going to do is I'm just going to erase these 2. and I'm going to take the 20.5. All right, but actually I just want one of them, so let's just erase that guy right there. Okay, so now that we have 20.5 over here and we have 20.5 over here, we want to check to see if the perimeter actually is 63, because that's what they said we wanted it to be. So take 20.5, 20.5, 11, 11, add them all up, and they actually do make 63. So we got the right answer. All right, let's try one last one. So example number 3, a square has an area of 100 centimeters squared. What is the side length of the square? Okay, so let me get out my pens. So the first thing they told us was that the area is 100 centimeters squared. So I put that right in the middle, and remember that the area is this inside part. Okay, it's not the outside, it's the inside of the square. Okay, now what they want to know is what is the side length. So I have that in blue right over here, and because it's a square, all the sides are the same, so I just put S for side. So all these are going to be sides, and I don't know what any of them are. Okay, so that is our picture right there of a square, and what I want to do next is I want to make an equation. Okay, so my equation is going to be, do you guys remember what the area equation is? So area is length times width. So it's not the same as the perimeter where you add up all the sides, it's you times the length and the width together. So this is a different formula. All right, so right there, length times width. Now the length is S and the width is another S. So I put S times S instead. And we already know what the area is. They told us what it was. It's 100 centimeters squared. So I just replaced the A with 100. Now this is a lot easier to deal with, and this is the equation that I'm going to use in order to solve now. So that's my next step. I'm going to take that equation and I'm going to solve it. So my 100 is equal to S times S, and you know what? S times S, we kind of went over this before. S times S is S squared. Okay, so that's why I have an S squared here. All right. Now, we're going to have to go through steps in order to solve for S by itself. So do you see how the S is stuck to that 2? In order to get rid of that 2 and bring it to the other side, we have to do the opposite. And so the opposite of squared is actually the squared root thing. So let me get my highlighter again, and I'll do that right here. So this square root right here, this square root symbol, I don't know if you can see that. You know what, let me use a different color. This square root symbol is the opposite, and we have to do it on both sides of the equation because those are the rules of solving equations. And so when we do the opposite of this with the square root, you're going to be left with just the S by itself. Now if you do a square root on your calculator, a square root basically means what number times itself will give you 100. And so you'll get the answer 10 because 10 times itself, 10, will give you 100. And that means that the side length, so the side length is 10 centimeters. So again, don't forget to do your little conclusion sentence over here, and especially don't forget, always remember, don't forget to do the units, centimeters, okay, because they had said centimeters right there. And we use centimeters, not centimeters squared, because centimeters squared is for the area. Centimeters is for a measurement. So you basically said this is a 10, and that all of them are 10s. So let's just check to make sure that your answer makes sense. So if this guy is also a 10, then the area is length times width, 10 times 10, and that gives you 100. So you got the right answer. All right, so this is how we start to use solving equations in order to tackle some word problems. So your homework is going to be going into the textbook and doing these questions right here. And if you need help, you can always email me. Okay, have a great day.